So normally I kind of dread making these videos, just being honest, but this one I actually look forward to because I don't know if you remember, trigonometry is my favorite. And a lot of you are probably thinking, Miss Lambert, why the heck would this one be your favorite? Because it makes so much sense. There's so much connections between so many things. And it was probably confusing for you because you were just learning it, but the more you think about it, and like every year that I've taught it, I learn more things about how it makes connections, and it's just so cool to me. So, and funny I say so because let's start with SOHCAHTOA. Or I guess even before we get into SOHCAHTOA, we should probably define what trigonometry even is. Here's what you need to know. Every non-right angle in a right triangle is associated with a specific ratio of side lengths. That's all trigonometry is. It's just how do angles in a triangle relate to the sides that make them. That's it. And so with SOHCAHTOA, that's the names of our trig ratios. We have sine, cosine, and tangent. So if you remember, sine was opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, color coding, excuse me. Tangent, opposite over adjacent. So write out sine from your reference angle. Remember, theta just represents a reference angle. So you could see it as like sine theta, sine 35 degrees. Like it's just representative of an angle. So cosine from your reference angle, adjacent over hypotenuse. Tangent of your reference from your reference angle is opposite over adjacent. So let's put theta up there. There's my reference angle. And let's say I got 5. Let's say I got 12 and 13. All right. The side directly across is going to be my opposite. Hypotenuse is always opposite from the right angle, so it's always the hypotenuse. That leaves our other one to be adjacent. So the one that creates the reference angle with the hypotenuse is adjacent. So if I want sine theta, well, opposite over hypotenuse is 5 over 13. And that's it. If I want cosine theta, I need adjacent over hypotenuse. So that's 12 over 13. And tangent of theta is opposite over adjacent, which is 5 over 12. Let's say I was missing a side length. So this time theta is going to be down here. And we'll keep this, I know we're just going to make up some numbers. 7 and 14. Well, if I'm missing a side, and let's say I want to find sine theta. Well, here's opposite, adjacent, hypotenuse. Well, I need that opposite side. So what do? Pythagorean theorem. So a squared plus 7 squared equals 14 squared. I'm just going to type that much into the calculator right now, the 14 squared minus 7 squared. 14 squared minus 7 squared is 147, which means I have to square root that. And I believe 147, oh, it's not a prime number because it's divisible by 3. Look at that. 49, 7, 7, bam. A equals 7 square root of 3. Which means sine is sine is opposite over hypotenuse, which reduces to root 3 over 2. Okay. So with that, we can use, because we know that every angle is associated with a specific ratio of side lengths, we can find missing sides and missing angles using trig. So let's call this 41 degrees, and let's say that this side is going to be 8.6, and I want to find the value of x. Well, we can use trigonometry for this, where I label these sides. I know I have opposite and adjacent, and I'm just going to go through SOHCAHTOA and say, all right, well, which ratio uses opposite and adjacent? Well, that's going to be tangent. So I know tangent of 41 degrees, because that is my reference angle, equals opposite over adjacent. Your goal here is to get x by itself. And so I'm going to do that by multiplying both sides by x. I'm going to do that in a different color. So I get x tangent of 41. Those cancel and I get 8.6. And now we divide both sides by tangent 41. Now I'm going to say this, and I'm going to write it down. You best make sure your calculator's in degree mode. So if not, you're going to have a lot of sad incorrect answers. All right, I'm going to type that into my calculator. 8.6 divided by tan 41. And I get 9.89. And I'm just going to round that to 9.9 because 8.6 is to 1 decimal place, so this answer will also be to 1 decimal place. Well, let's say I also have a missing angle. So let's put theta down here. And I know I have, 17 and 12.2. And my job is to find theta. Well, here's what I know. I have the hypotenuse and I have the adjacent, which means that I know that cosine of theta equals adjacent over hypotenuse. Well, to find an angle, we are actually just going to use the inverse trig. Inverse trig, all that does is match an angle to its ratio. So I know that theta is actually going to be cosine inverse. Why did I write h when it's 17? 12.2 over 17. And I'm just going to type that in my calculator with the second button. So I got cosine inverse, 12.2 divided by 17. I get 44.14 degrees. It occurs to me that maybe you want one more example with finding a side. just going to do the same thing, opposite hypotenuse. Well, I know that's going to be sine. Well, if you're going to find a side length, you better actually know what that angle equals, huh? Let's try that again. Let's make it 24 degrees. I have opposite and hypotenuse, which tells me that I'm going to use sine of 24 degrees equals x over 4. Well, you have to get x by itself, so I'm just going to multiply both sides by 4. So I get 4 sine 24 equals x, and we're just going to type that into the calculator. 4 sine 24. And I get 1.63. The only other thing as far as like this goes is just remembering the difference between the angle of elevation and angle of depression. Now, I remember a lot of you treated these like they were different, but spoiler alert, they're the same thing. This is the angle created by the base and the hypotenuse of the triangle. And I know a lot of you get confused because, well, I could have a triangle that looks like this, or I could have a triangle that looks like this. Well, like I said, they're the same thing. I'm just labeling these dimensions so you can see what I'm talking about. The base and the hypotenuse. There you go. The base and the hypotenuse. There you go. And if you wanted to get specific, a lot of the times we'll call this one elevation and this one depression. But honestly, I don't even want you to think about that because I just want you to think about it's the angle created by the base and the hypotenuse. So we could say a bird is in a nest. "12 meters off the ground." Bob is standing 6.3 meters away from a point directly below the nest. What is the angle of depression between the nest and Bob? So here's what we got. I'm going to assume that this nest is in a tree. Branch, nest with a bird in it. And Bob's going to be over here. And I can look at this drawing in two different ways. I could draw it this way, and there's my triangle where I got 12 here and 6.3 here. Or if I did it a different way, just bird, getting really good at this. And then Bob, tree taller. Or I can make my triangle this way. Technically, if I am talking about here, this would be 6.3 because that's the spot below, and the height from there is 12 meters. I'm not saying Bob's 12 meters. I'm saying that that height between the branch and the nest and the spot above Bob is 12. So if I was being really technical, angle of depression would technically be this one. But guess what? If I'm looking at it as the angle created by the base and the hypotenuse, those are congruent angles. It doesn't matter which way you draw it, but you best have it between the base and the hypotenuse. Because then it's just going to be the same thing. Opposite, adjacent, tan theta equals 12 over 6.3. So I know I need to use inverse trig to find the angle. Wait, is it going to be the same if I did it over here? Opposite, adjacent, tan theta equals 12 over 6.3. Oh, would you look at that? It is the same. Tan inverse 12 divided by 6.3. 62.3 degrees, no matter which way you do it.